welcome to Maths Live. Here are your 2 challenge questions, recapping yesterday's lesson. And here is a little note at the big bottom saying, I'm sorry, I forgot to post the 3 challenge questions for today's lesson. It just completely slipped my mind. I was quite busy this morning, so have a go at these 2, post your answers. And the shout outs today, I'm actually not going to look for your names and your shout outs, but shout out to your school. What is your school name? Give them a big shout out. Unless you're homeschooled, obviously, you can still shout out your name. But I like to hear about all the different schools that you go to around the country. So carry on with the challenge question. I'll be back in a second, just looking at all your shout outs. I can get my computer to work. Here we are. Okay. Hello Ava. Hi Amelia in Sheffield. Hello Amelia. Hi Harry in Nottingham. We've got some answers already. Fantastic. So we've got South Hill Primary School, I'm guessing. Okay. Richard Bonington Primary and Nursery School. Wow, that's a really nice name for a primary school. Hi Grace and Hattie. Hello. That's a really cool name for a primary school. What was it again? Richard Bonington. That's a great name. I presume that's named after someone called Richard Bonington. Right, so again, yeah, sorry for the 3 challenge questions. Okay, so we want to convert these mixed number fractions into improper fractions. Now, remembering how to do this. This 2 basically means 2 whole lots of the fraction that we're given. The fraction is the quarters, okay? So this 2 actually means 4 over 4 and 4 over 4. Because this is 1 whole and this is another 1 whole. And 1 whole plus 1 whole is 2. So we've got 4 over 4 and 4 over 4, and then we've also got the 3 over 4. So over 4, that is 4, 8, 9, 10, 11. Okay. Now the other way of doing it that I showed you was that you can multiply the whole number in the denominator. So you multiply those together. 2 times 4 is 8. And if you add the numerator, 8, 9, 10, 11. And you get the same answer. Now we're doing it the other way, doing it the same way around this time. So we're converting the mixed number into an improper fraction. So let's do it the short way. The answer is going to be over 5. Because the fraction that's in the mixed number is already over 5. So we times the whole number by the denominator. So 7 5s are 35. And then we add the number in the numerator. That's 38. So it's 38 over 5. Now I know we practiced converting them the other way around, but this was just a warm-up. Right. Topic number 3. It's already Wednesday. So today we're going to be adding and subtracting fractions. Going to start off with what I think is the basic way, the easier way, the less complicated way to add and subtract fractions, the nicest way. And then in the second part of the lesson, I'll push you further onto the harder way. Now, what do we mean? When would you add and subtract fractions? Okay, so imagine you've got something over 8, and maybe you're adding something over 8. Now, a really good example I was thinking of, because last night we ordered pizzas. Me and my husband ordered pizzas from a reputable national pizza company. I'm not going to say the name because this goes onto YouTube afterwards. So, and each of our pizzas was split into 8 parts. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And this was my pizza, same size, different flavours. Okay, now, I ate quite a lot. I was hungry. I ate 1, 2, 3, 4, 5 slices of my pizza. So I ate 5 eggs. Now, my husband was very greedy. I have to whisper because he's downstairs. And he ate all of those. Okay, so he had 1/8 of his pizza left. I had 3/8 of my pizza left. And we took those pieces of pizza and we put them in the fridge and we're having them for our lunch today. So how many pieces of those pizzas have we got left? Well, there's 1/8 here and there's 3/8 there. So 4/8 of the pizza is left in the fridge. Okay, so that's a good example where you might add or subtract fractions. If you're subtracting fractions, okay, I could say that out of my whole pizza, if I look at my pizza, I started with 8/8, started with 8 pieces. I ate 1, 2, 3, 4, 5 pieces. So how many pieces did I have left as a fraction? 3 out of 8. And this is nice. As you can see, the denominators don't change. So if the denominators of the fraction are the same, it's actually quite easy. So another example. I might have 5/6 and I subtract 2/6. Well, the denominators are the same, so I can keep the same denominator in my answer. So I just do 5, take away 2, which is 3. 3 out of 6. If I have, say, 3/12, and I add 4/12, that means I've got 7/12. It could be that, I don't know, a group of children eat some chocolate, got some chocolate bars, and they might have a load of pieces left over that are all the same size, so they might put them in a bucket and save them for tomorrow, and it's how many parts of those fractions from each of their chocolate bars have they got left. Show you one more. I could have, I don't know, 9/10, and I subtract 1/10. Even if it's subtraction, do the same. So the denominators are the same, so you can keep the denominator the same. And now take away 1 is 8. So it's lovely when the denominators are already the same. Your turn now. 3 questions. I don't think this will take very long. So you've got 1/4 plus 1/4, 8/10, take away 5/10, and 2/18 plus 10/18. Have a go at those while I see how you're all getting on. Okay. South Hill Primary School, Gilwern Primary School. By the way, if you just joined in, we're shouting out the primary schools that we go to. Gilwern Primary School, amazing. Oh yes, because Iona is at the school of Mummy, Steph, Holly and Lara. I love that. Junction Farm Primary School, because it used to be a junction which was next to a farm. I love that. Brilliant. Yeah, we're all marching through the answers. I really like in our village, because I live in a village called Buckshaw Village, and it's got a primary school. But there's also, there's a primary school outside the village called Buckshaw Primary School. It's not in Buckshaw, so I think that's quite funny. Right, so the denominator stays the same, because they're already the same. So you just add the 1 and the 1. 2 quarters. The denominator is already the same, so we keep it the same. 8, now always check, don't think, oh, 8 plus 5 is 8, take away 5, which is 3. And then the denominator is already the same, 18, so we do 2 plus 10, which is 12. If you're in year 6, you might be asked to simplify your answers, but I'm not doing simplifying fractions today or this week because that's just an extra skill. I want you to learn the skill of adding and subtracting fractions. Simplifying is just an extra part of that. If you know how to simplify and you want to go for it, go for it. But like I say, I'm going to keep to the specific skill. Now then, when you're adding and subtracting fractions, the denominators are not always the same. And we need them to be the same. And this goes back to Monday's lesson when we were doing equivalent fractions and comparing fractions. That's why I started the week with that. Obviously, don't worry, if you're not too sure about this, it's great practice. Because we might be given the question such as 1/5 plus 2/3. Now, in an ideal world, you might say, okay, Steph, don't worry about it, because we're talking about adding and subtracting fractions. So we'll just add the 1 and the 2, which is 3, and then we add the 5 and the 3, which is 8, and the answer's 3/8. It's not. Unfortunately, when you add and subtract fractions, the denominators have to be the same. You need to convert them so that they are the same, from the same parts, because you can imagine a 1/5 slice, if you have a 1/5 slice, there's going to be a different size to a 1/3 slice. We need to equal them out. We do this, and if you remember this, we need to find the same fractions. So we need to change these fractions so they have the same denominators, and the easiest way to do it is get a common multiple of 5 and 3. And I'm thinking, what, a common multiple of 5 and 3? Easiest way to do it, 5 times 3. 5 times 3 is 15. Oh look, we have a common multiple. Excellent. Right, what did you do to 5 to make it into 15? What did you times 5 by to make it into 15? You times it by 3. When you're changing these fractions, again, you need to multiply or divide. Okay? We can only add and subtract when everything is already the same. 5 times 3 is 15. Whatever you do to the bottom of a fraction, you do to the top. So 1 times 3 is 3. Same on this side. What did you multiply 3 by to make it into 15? You multiplied it by 5. Do the same to the top. 2 times 5 is 10. Brilliant. Now our fractions have the same denominator, which is 15. So we do 3 plus 10, which is 13. So the answer is 13 over 15. And you actually can't simplify that anymore. Okay, show you another example. 9/10 take away a quarter. Right. Denominators are not the same, and we need to make them the same. It's a subtraction question. Easiest way to do it, I'm going to multiply the denominators that I've already got. So, 10 times 4 is 40. What did I times 10 by to make it into 40? You can see it's the opposite number. 10 times 4 is 40. So I do the same to the top. 9 fours. 1 9 is 9, 2 9s are 18, 3 9s are 27, 4 9s are 36. Right. Now, what did I times 4 by to make it into 40? Times it by 10. Do the same to the top. 1 times 10 is 10. Now we can complete the question. 36 over 40, subtract 10 over 40. 36, take away 10 is 26. Now, you could simplify that answer, but don't worry about that today, because we're focusing on the skill of adding and subtracting fractions when the denominators are not the same. I'll show you one more. 3/7 plus 1 over 8. Right, we need the denominators to be the same. Quickest way, 7 times 8. 7 times 8 is 56. We're adding. Always check if you're adding or subtracting. You can get really carried away with changing the fraction and then forget whether you're adding or subtracting. Right, what do we times 7 by to make it into 56? 7 times 8 is 56. Do the same to the top. 3 8s, 1 8 is 8, 2 8 is 16, 3 8s are 24. What do we times 8 by to make it into 56? 7 8s are 56. So do the same to the top. 1 times 7 is 7. Our denominators are both now at 56. So we do 24 plus 7, which is 31. So the answer is 31 over 56. Okay, I know there's a lot more steps, but you saw how easy the first part of adding and subtracting fractions when the denominators are the same. So this is, if you get that, this is just where you're up to, okay? And it's great that you're up to this part. Right, your turn now. I'm going to do it just 2 at a time. So 4/5, take away 1/3, and 1/6, add 2/7. Have a go at those two. 4/5, take away 1/3, and 1/6, add 2/7. It's gone dark in here again, hasn't it? Oh, the north and its rain. Right, let's see how you're getting on. Ta-da. Whoa, so many comments. Brilliant. Well done. Fantastic. Yeah, don't worry if you're confused. Like I say, it is quite tricky. Okay, Harry's had a go. Ava's having a go. Yep, a lot of timesing in this, yes. This is where our timetables get really important. Don't worry if you get it wrong, best thing you can do is have a go. It's thinking, how can you get those denominators to be the same? So let's have a look. 4/5 take away 1/3. So let's times the denominators together. 5 times 3 is 15. And we're subtracting. Okay. Now, how did we change 4/5 so the denominator is 15? Now, to change 5 into 15, we times it by 3. So we do the same to the top. 4 times 3 is 12. How do we change 1/3 so the denominator is 15? We did 3 times 5, which is 15. So we do the same to the top. 1 times 5 is 5. And then it's raining really hard outside. Sorry, it's like, I don't know if you can hear it. It's really raining really hard. So we do 12 over 15, subtract 5 over 15, which is 7 over 15. So well done if you got that. I saw a couple of people. Brilliant. Okay, next one. Times the denominators together. 6 7s are 42. Oh dear. What did you times 6 by to make it into 42? You times it by 7. So do the same to the top. 1 times 7 is 7. How do you change 2 7s so the denominator is 42? 7 times 6 is 42. So do the same to the top. 2 times 6 is 12. And then 12 plus 7 is 19. So the answer is 19 over 42. Well done if you got that. Don't worry if you didn't. Like you've said, it's tricky. Do one more. Okay, last one. over 12 plus 1/2. And to help those of you who are not sure, I'm going to tell you that the denominator is 24. Because, and think, what do you multiply these numbers by to make 24? Particular shout out to Ava, well done for doing this, you're doing really, really well. And by the way, I saw a couple of comments there about what type of fraction. Don't worry if the fraction is an improper fraction at the end, as long as you've done the method. Sometimes the answer can be an improper fraction. Okay? I'll show you an example of that in a second. Right, what did we times 12 by to make 24? We times it by 2. So do the same for the top. 3 times 2 is 6. What do you times 2 by to make 24? You times it by 12. 2 12s are 24. So you do the same to the top. 1 times 12 is 12. And then you add those two together. That's 18 over 24. I love that comment about improper fractions. I'll just show you quickly an example of when your answer will be an improper fraction. So you might have, you can do this with me, you might have 5 over 6 plus 8 over 9. Okay? So you times these two together. So 1 9 is 9, 2 9s are 18, 3 9s are 27, 4 9s are 36, 5 9s are 45, 6 9s are 54. So you need your times tables. Okay. What did you times 6 by to make it at 54? Times it by 9. So 9 5s, 45. What did you times 9 by to make it into 54? 9 times 6 is 54. So do the same to the top. 8 6s are 48. Whew, this is going to be a big improper fraction. So we've got 45 plus 48. So that's 13, 8, 8. 93 over 54. That's fine. That's absolutely fine. Okay? It's the correct answer. You've worked through it the correct way, so don't ever freak out if your answer is an improper fraction. Okay? That's still the correct answer. Right. Whoop. Stay still, poster. Well done today. I know that's tricky, that last part, but that's where a lot of you are up to, so well done for giving it a go. Of course, I'll put a challenge question up on the page after this. Tomorrow, we're multiplying fractions, which sounds terrifying, but if anything, it's actually easier than this. So hopefully I'll see you tomorrow. Enjoy the rest of your day. Bye-bye.